Dear students, in this video we are going to see 1.5 and 1.6. Okay, what is here? Cartesian form of a complex number, that is z is equal to x plus iy. Okay, what is a polar form of a complex number? That is z is equal to r sin theta plus I r sin theta is equal to, we can write r e power I theta. Z to the power n is equal to r to the power n cosine n theta plus I sin n theta. This is nothing but z to the power n. Okay, but here what we are going to see the new idea, that is nth root of a complex number. See here, this is the given complex number in polar form. What is the nth root? What we are going to see, nth root. See, nth root is nothing but z to the power 1 by n, z to the power 1 by n, that is nth root. Okay, here z to the power 1 by n is equal to, we can write like this, otherwise we can write z to the power 1 by n is equal to, here r to the power 1 by n, this is r to the power 1 by n. See here, r to the power 1 by n is nothing but, here put root symbol inside, or here you put n, that is r to the power 1 by n. So here r to the power 1 by n cosine theta plus 2 pi k divided by n plus I sin theta plus 2 pi k divided by n. This is nothing but z to the power 1 by n, that is nth root of a complex number z. Okay, here what is k? Here what is k? Now what is k? K is nothing but 0, 1, 2, etc. n minus 1. Here if n is 5, then k is 0, 1, 2, 3, 4, because the last value of k is n minus 1. Okay, now you see this question, find all the sixth roots of 1. Okay, that is 1 to the power 1 over 6, or you can write this c root of 1, here you can put 6, both are same. Okay, sixth root of 1. Okay, now what we are going to do to find sixth root of 1? First you write here value of n. What is the value of n? Value of n is nothing but here 6, so n equal to 6. Now we have to write the given complex number first in polar form. Okay, so polar form we know that. To write the polar form, what we have to find? We have to find r and theta. We know that how to find r. R is equal to square root of a square plus b square. Okay, here only we have the value of a, b is 0, so that r is equal to 1. Now what is theta? Theta is equal to 0. Why? Because you see here in this complex number, here real part is 1, so this is on the real axis, so here angle is 0, theta is 0, so that here theta is 0. Okay, so now you substitute r and theta in the polar form, so that you can write the complex number z is 1, that is equal to, here you see what is here, r, so r is 1, then cosine theta is 0, I sin theta is 0, that's it. This is the polar form. Next we have to find the sixth root of the complex number, that is z to the power 1 by 6 is nothing but, z is 1, so 1 to the power 1 by 6 is nothing but, this is the rule here discussed in slide 2. Now see r to the power 1 by n, so now here r is 1, 1 to the power 1 by 6 cosine, this is theta plus 2k pi over 6. Similarly you write it here. Then what is k? We know that k starts from 0, here last number is n minus 1. What is n? N is 6, so that now here this is nothing but 6 minus 1, that is 5. So k is equal to 0, 1, 2, 3, 4, 5. Total values are 6, but from 0 to 5. Okay, now for each value of k we have to write the value of this. Okay, substitute the value of k here. Now k is equal to 0, first value k is equal to 0, you put here k is equal to 0. So if k is equal to 0 means this 0 plus 0 divided by 6, and the number 0 divided by any number is 0, so cosine 0, that is cosine 0 plus I sin 0 is equal to 1. You find the value of cosine 0 in the calculator, use radian mode. Similarly here find the value of this one, so here 1. Okay, so now k is equal to 1. If k is equal to 0, this is the value. Now similarly, you can substitute k is equal to 1 here, k is equal to 2 here, 3, 4, 5. Okay, similarly you can write all the values for this one and this one. You can find the value in the calculator. Okay, that's it. Now we'll say another question. Find fourth root of 1 minus I root 3. Okay, now here what is the n? 4. Okay, next we have to write polar form. To write polar form, we have to find r and theta. Okay, now what is r? That is square root of a squared plus b squared. So you write a is 1, b is minus root 3, so that r is equal to 2. Okay, now what is theta? Theta is equal to, now you see theta in the fourth quadrant. Okay, see the graph. Okay, see the graph here. Theta in the fourth quadrant. So now here theta is equal to minus alpha, we are given in the last video. So now minus tan inverse of b by a. B is minus root 3, a is 1. Here this is a, this is b. Okay, so now substitute here. Here this is modulus, so minus tan inverse root 3 will come. You means cancel this negative because modulus, so that you can leave that one, so that is equal to minus tan inverse root 3, that is nothing but minus 5 over 3. So we know that r and theta. Now you substitute r and theta here in this rule, so that we can write the polar form. 2 times cosine minus 5 over 3 plus I sin minus 5 over 3. Cosine minus theta, cosine theta. So sine minus theta, you will put minus outside. Okay, now we are going to write fourth root of z, that is z to the power 1 by 4 is equal to 1 minus I root 3 whole to the power 1 by 4. This is nothing but you use the rule. Okay, this one, use the rule, so that now here I can write 2, r is 2, so 2 to the power 1 by 4 cosine, now theta plus 2k by 4 plus I sin theta plus 2k by 4. Okay, by using the rule. Okay, now what is k? We know that k starts from 0, and then here you stop n minus 1. Here n is 4, so 4 minus 1, 3. Okay, now what we have to do, as we did in the previous question, we have to write the value for, means we have to write the value of this fourth root of z for each k. K is equal to 0, 1, 2, 3. Now here put k is equal to 0. If k is equal to 0, this is minus 5 over 3 divided by 4, so 12. So cos 5 over 12 minus I sin 5 over 12. Okay, for k is equal to 0. Similarly, you substitute k is equal to 1, k is equal to 2, k is equal to 3 in this equation. Okay, so that you find all these 4 values. See, if you want to simplify, you can find the value of this in the calculator by using radian mode. Similarly, you can find the value of this in calculator using radian mode. Then you can write the simplified form of the number. Okay, that's it. Now let's say another question. Now you see here, find 2i over 1 plus I to the power 1 by 3. Here this is third root. Okay, so n is equal to 3. Okay, now here two complex numbers given in the question. One is in the numerator, one is in the denominator. Okay, now in the numerator z1 is 2i, so that find r1 theta 1 to write in polar form. Now z2 is 1 plus I in the denominator, so now write r2 and theta 2. Okay, see how to find theta. You see this graph, you understand, already we explained in 3-4 questions. Okay, now how to find theta 2 here from this graph? Yes, you can understand. Now after finding r1 theta 1, r2 theta 2, now this rule is discussed in the previous video. Okay, now so now here z1 z2, that is 2i and 1 plus I, so that you use this rule. Now find r1 by r2. See, r1 by r2, that is root 2. Now theta 1 minus theta 2, that is 5 over 4. So what you do, you substitute r1 by r2 and theta 1 minus theta 2 in this rule, so that you can find the polar form of the given complex number. Okay, so now this is a polar form, this is the polar form. Okay, but what we have to find, we have to find third root of the polar form. Okay, now go here, 2i by 1 plus I whole to the power 1 by 3, because third root of the complex number, that is equal to, now here r is equal to root 2. So now root 2 means 2 to the power 1 by 2, but here we have 1 by 3. So that, see here, listen carefully, so that I am writing 2 to the power 1 over 6. Okay, then this is simple, cosine, put theta plus 2k by, here also theta plus 2k by divided by 3, because here this is third root. Okay, now k is equal to 0, 1, 2. We know that k is equal to 0, 1. This is the number n minus 1, that is n is 3, so 3 minus 1, that is 2. Okay, now what we have to do now next, see, put k is equal to 0 in this equation, write the value of the complex number, then put k is equal to 1, then put k is equal to 2, you simplify it, you write the value of this one. Okay, so k is equal to 0, what is this, 2 power 1 by 6 cosine pi over 12 plus I sine pi over 12. Okay, from this one. Okay, similarly you can find for k is equal to 1 and 2. Okay, that's it. Next, you see, solve z squared minus 2i plus 1. What is a, b, c from the question you can write, because this given question is in the quadratic form. Okay, use quadratic formula to solve this. Substitute all the values of a, b and c, so that you find 1 plus or minus square root of 1 minus I. Okay, now you see here, listen here carefully, this is the second root of the complex number 1 minus I. So that to simplify this, we have to make use of the previous method. Okay, so now here, what is the complex number? 1 minus I. So 1 minus I. Here how to find r and theta? We know that r is equal to square root of 2, because here a is 1, b is minus 1, so square root of 2. Theta, how to find theta? That is in quadrant 4. Okay, theta is quadrant 4, because here you see 1 minus 1, that is here in quadrant 4. So that theta is equal to minus tan inverse of modulus minus 1 by 1. Okay, so here we have modulus, so you can leave this symbol, so that minus tan inverse of 1, that is tan inverse of 1 is pi over 4. Already we have 1 minus, so minus pi over 4. So now r and theta we know that, so we can write in polar form first. So 1 minus I is equal to r cosine theta plus I sin theta. R is root 2. Okay, here then theta is minus pi over 4, you substitute here. So this is the polar form of the given complex number. This complex number, you see 1 minus I. Okay, now we have to write the second root, means 1 by 2. Here we have 1 by 2, so that here 1 minus I whole power 1 by 2 is equal to, we know the rule, here root 2, which means 2 power 1 by 2. Already we have here 1 by 2, so that 2 power 1 by 4, so that we can write theta is equal to minus pi over 4 here. Okay, so you will get this form. Now here we know that k is equal to 0 and to 1. Okay, but we have to solve this. See, we have to solve this quadratic equation. So the final answer is z is equal to, you see, this is very important, these are the roots of z. Z is equal to 1 plus or minus. So see here, z equal to 1 plus or minus, and then for this one, square root of 1 minus I, we have calculated this. Okay, so here what you put for k is equal to 0, if you put k is equal to 0 in this form, what you are getting, you have to write here. So put k is equal to 0, this will vanish, so that cos minus pi over 8 will come. So cos minus is cos, so here minus I sine, here this will be 0, because for put k is equal to 0, then you write this value. These are the roots of the given equation. Okay, now in 1.6, see, we are going to see few definitions, that is open disk, open unit disk, closed disk, open set, closed set, bounded set, region. Okay, just you can see, you can go through these definitions in net, or you can refer in the book, or you can see in Google. Okay, that will help you to tick in multiple choice questions sometimes. Okay, thank you.